Hello. Okay. Good evening. Can you hear me? Okay. Give me a second. Okay. What we discussed? We discussed about mixture method, right? Mixture method. Finally. Okay. The mixture method very simple. I gave three homeworks, no? Three homeworks. Give me a second. Okay. We discussed about mixture method. Mixture method. Uh, what's the meaning of mixture method? I told if you mix two or more substance with different temperature like this. Think it is a calorimeter. Calorimeter is a thermal insulated vessel. Thermal insulated vessel. It is water. If we add unknown or known or whatever heated substance, Now think water temperature 30 Celsius. It is 100 heated cells, heated substance. If we add and mixing, then what happens? Hot body, that means heated substance releasing, always heat releasing, and the cold substance heat absorbing, right? The heated substance release heat equal to the if there is no any heat lost, if there is no heat lost, the heated substance release heat completely equal to the cold substance absorb heat. That's explained about energy conservation, right? We discussed about energy conservation law. According to energy conservation law, it's explained energy cannot be destroyed or create. That means the heat is energy, the heated substance release heat completely equal to the cold substance absorb heat. Okay, that's a mixture method. Actually, this mixture method actual usage is not the calculate final temperature, but last week we did some calculations to find the final temperature, right? They are just calculations, but this is not the practical application. The practical application is to find the specific heat capacity of unknown material, again unknown substance, right? This is a method. This experiment, think it is 1 kilogram unknown metal piece, unknown metal cube, we don't know what is the type of metal or anything, we don't know about anything, this metal, right? Now it is an unknown metal, we can measure the mass, think it is 1 kilogram, and think it is 5 kilogram of mass at 30 Celsius. Initial temperature water 30 Celsius and 100 Celsius, 1 kilogram of metal piece. We don't know what is the type of metal, right? Then we can mix these two substance, water and metal cube. We can mix, then we can get the final temperature of mixture. Final temperature means equilibrium temperature, right? Think equilibrium temperature, equilibrium temperature, equilibrium temperature. Equilibrium temperature 40 Celsius, no 50 or 60 Celsius. 60 Celsius is the equilibrium temperature, right? Then we can get the metal piece release, the heated substance release heat equal to the cold substance, water and calorimeter absorb heat, water and calorimeter absorb heat, and isolate the specific heat capacity of unknown metal, right? Isolate the specific heat capacity of unknown metal. Okay. Yumit, what is the final question we discussed last day? What's the final question we discussed? In heat method, heat में mixture method. तीनों. We discussed only 9 until 30. Very good. We did until 30. Then today you have only 3 questions, no? Or 4 questions. 40. 40. Homework 10 and 11. 10 and 11 homework. Yes. 10, 11, we did 12 and 13. 14, 15, 16, 17 homework. We should discuss 10, 11, 14, 13 discuss, right? 13 is covered. 10, 11, 14, 15, 16. Okay, let's discuss. 10, 11. Okay, 10. A piece of copper of mass 200 gram at 100 Celsius is placed in 300 gram of water at 20 Celsius. The specific heat capacity of copper is given 390 joules per kilograms per Kelvin. The water specific heat capacity also given 4200. 4200, the final temperature of the mixture, and neglect the heat loss. Neglect the heat loss. Neglect the heat loss. Hadam. Okay. This is a story. This is a water. $300 of water at 20 Celsius. 300 of water, 20 Celsius. At 200 of metal cube, copper cube, 200 of copper cube at 100 Celsius. Mixing. Just mixing. Right? Mixing, and the question asks what is the equilibrium temperature, the final temperature of mixture. I told always is stable equilibrium. Final temperature is always between 20 and 100. It's always 120. The final temperature, it is greater than 20 and less than 100. Greater than 20 and less than 100. Greater than 20 and less than 100. That's very important to get the temperature difference. Now, what happened? According to mixture method, copper cube release heat. Copper cube is a substance releasing heat, right? Copper cube release heat equal to the copper cube release heat equal to the water absorb heat. Water absorb heat. Water absorb heat. Water absorb heat. Okay. Now copper cube, the specific heat capacity is given. The specific heat capacity is given. Then it is mc theta equal mc theta. C means Cw, water. It is copper. Theta. Right? The mass of copper, 200 grams. 200 divided into 1000 to convert into kilogram. Into specific heat capacity of copper, it is 390. Yeah, it is given 390 joules per kilo, J kg minus 1, K minus 1. Temperature difference, what's the temperature difference? Nabil, what's the temperature difference? What's the temperature difference? Now, what happened to copper cube? It is 100 Celsius to reach to theta, final equilibrium temperature. No, Nabil. Not 80. Yeah. Understand, Nabil. Maya, this 200 gram of copper cube at 100 Celsius, when we introduce to the water bath, the water temperature is increasing and copper cube temperature is decreasing. And because heated substance heat releasing, cold substance heat absorbing. Due to this thermal exchange, what happened? Both cube and water come to same temperature. Same temperature means equilibrium temperature, middle temperature. This middle temperature is a theta. Good, Nabil? Then water temperature, what happened? Theta Celsius to reach to theta Celsius. Theta Celsius is the equilibrium temperature. Theta is the equilibrium temperature. Right? Now, what is the temperature difference? For copper cube, it is 100 minus theta. 100 minus theta equal, because 100 is greater than theta. Copper cube heat releasing and temperature decrease due to heat lost. Heat release, right? Heat release. Yeah. Then mass of water, water mass 300, divide 1000 to convert kilogram. Specific heat capacity of water 4200. Temperature difference now. Nabil, now what is the temperature difference? Now 20 convert into theta. Theta or 20 greater value? Theta or 20 greater value? Theta, yes. Because water temperature increasing and reach to the theta value, right? Therefore, theta is greater than 20. Therefore, theta minus 20 is the temperature difference. Okay, Nabil? Hi. Understand, right? Very simple. Now see 20 cancel out, 0 cancel. 20 cancel out, 0 cancel. Now 2 into 39, it is 78. No? 78, yes. 78 into 100, 78 20 minus 78 theta. 78 theta. Right now 3 into 420. 3 into 420 mean 1260. 1260 into theta. Theta minus 1000, so 1260 into 20. What's the value? 1260 into 20. Any doubt, please ask. And it's 1260 theta, 1260 into 20, 25,200. 25,200. Okay, now what's the next step? Theta terms get into same side. Theta ටික එක පැත්තට ගමු. It is 7,800 plus 25,200 equal 1,260 theta plus 78 theta. 78 theta. Hurry. Now get the sum of these two values. Sum of these two values. 7,800 plus 25,200. 33,000. Yeah, 800 plus 200. Yeah, 33,000. 33,000 equal 1,200, not 200. 1,300 value. 1,260 plus 78. It's 8. 1,338 theta. Now you can get the theta. You can get the theta. Theta equal 33,000 divided by 1,338. What's the answer? 24.66. 24.66 Celsius. This is the final temperature of the mixture. This is the final temperature of mixture. This is the final temperature of mixture. This is the final temperature of mixture. Okay, any doubt? Any doubt? Any doubt? Tinul? Okay, let's move into question number අපිට දැන් තියෙනවා කීයක්ද question 10 okay 1140 11 okay let's go 0.5 kilogram of iron block at 150 Celsius is dropped into 1 kilogram of water at 25 Celsius containing a copper calorimeter of mass 0.2 kilogram. Now it is little bit different. Now it is you have to careful. 0.5 kilogram of iron block at 150 Celsius. Now this is a water container. Now you have to consider the container as well because container also absorbing some heat. Right? Carefully understand. Okay, this is a metal cube. Metal cube. It is 0.5 kilogram of iron block at 150 Celsius. 0.5 kilogram. That means 500 gram. 150 Celsius. 150 Celsius is heated 1 kilogram of water at 25 Celsius. 1 kilogram of water 25 Celsius. Container and water both 25 Celsius, right? Calorimeter mass 0.2. Calorimeter mean container 0.2 kilogram and at the same temperature 25. Okay, it is the mass of M equal mass of calorimeter 0.2 kilogram. Yeah, 0.2 kilogram. 200 gram. The specific heat capacity of iron 460. The specific heat capacity of iron C equal 460 J kg minus 1 K minus 1. What else? Given data. The specific heat capacity of copper. Okay, copper mean this container. Container specific heat capacity. It is given copper specific heat capacity 390 J kg minus 1 K minus 1. What else given data? The water specific heat capacity given, the final temperature of the mixture is asking. Okay, now what happened? Who is heat releasing? Met me. Who is heat releasing? Metal block O, iron block O, water O calorimeter. How the heat release කරන්නේ? Who is heat releasing? Yeah, iron block heat releasing. Then you can write down the equation. The iron block release heat according to mixture method. Iron block release heat. Iron block release heat. Iron block release heat equal to the water absorbed heat plus container absorbed heat, because container also according to this question, container specific heat capacity also given, then container also absorbing some heat. Water absorbed heat plus water absorbed heat plus water absorbed heat plus calorimeter absorbed heat. Calorimeter absorbed heat. Water absorbed heat plus calorimeter absorbed heat. Okay, then iron block release heat, think it is iron block release heat mean iron block 152 heat releasing mean what happened to temperature? Heat drop the temperature up to theta Celsius, final temperature theta Celsius, 150 Celsius to theta Celsius. Water what happened? 25 initial 25 Celsius to theta Celsius. they contain also 25 Celsius to theta Celsius equilibrium temperature. At the end of this experiment, at the final temperature, metal block, water and calorimeter, all three substances in the same temperature, that we call as thermal equilibrium. That's a stable temperature, that's a thermal equilibrium or equilibrium temperature. Right? Himit? Don't you have class? Class තියෙනවා කිව්වද? අද නැද්ද? Okay. Okay. 150 Celsius iron block convert into theta Celsius iron block. 25 Celsius water increase up to theta Celsius. 25 Celsius metal may copper calorimeter convert to final temperature. Now all system equilibrium. All system equilibrium. Same temperature at theta Celsius. Theta Celsius. Right. Now 150 Celsius to theta Celsius, it is mc theta equal to mcw, cw mean water, theta plus mc copper theta. Now substitute values. Mass of iron block 0.5 kilogram. Specific heat capacity of iron block 460. Temperature difference of iron block. What's the temperature difference? Now theta and 150. What is the greater value? 150. 150 minus theta. 150 minus theta. mc theta. Mass of water. Mass of water 1 kilogram. Specific heat capacity of water 4200. Temperature difference of water. Temperature difference of water. What's the temperature difference? Theta minus 25. Theta minus 25 because the water temperature increasing up to theta. The theta is greater than 25. Theta minus 25. I got observe? Understood? The temperature difference? The temperature difference is the most important thing. Others are just given in the question. Theta minus 25. Theta minus 25. Right. Then plus the mass of calorimeter, it is 0.2 kilogram into calorimeter specific heat capacity, that means copper 390. Temperature difference of calorimeter. Temperature difference of calorimeter, Nabil. Temperature difference of calorimeter. Temperature difference of calorimeter. Yeah, very good. Theta minus 25, same. Theta minus 25. Theta minus 25. It is same as water, right? The container temperature difference same as water temperature difference. Right. 0.5 into 460. 460 divided into 2. 230. 230 into 150. What's the value? 230 into 150. 230 into 150. 34,500. 34,500 minus 230 theta. 230 theta equal 4,200 into 1 same 4,200 into theta 4,200 theta minus 4,200 into 25 105,000 plus 0.2 into 390, it is 78 into theta 78 theta minus 78 into 25 78 into 25 1950. Now same method you can get theta terms into one side and other values into another side. 34,500 plus 105,000 plus 1,950 equal 4,200 theta plus not plus 4,200 theta plus 78 theta plus 230 theta. Hurry, get the value, get the theta. මේ පැත්තේ sum එක ගන්න, මේ පැත්තේ sum එක ගන්න, divide කර. Yeah, what's the final temperature? Thirty-one point 37. Yes, 31.37 Celsius is the temperature. 31.37 Celsius. Do we need to round it and write later? No problem. 31.37. Round off into second decimal point. That enough. 38 or 37. 38, no? Yes. Okay. Then 14, 15, 16, 17, no? 14, 15, 16, 17. Okay, it's a good question. Yeah, correct, Messi. Yeah, the 14 is a good question. I got the answer. Who got the answer for question number 14? It's a good question. The question asks steam at 100 Celsius. You know, steam in water vapor. 100 Celsius is a boiling point or condensed temperature. Boiling point hari condensed in a temperature, right? Now, if it is steam, it is condensed temperature. It's no specific name. Condensed temperature, right? Condensation in temperature, right? It is 100 Celsius passed into 500 gram of water at 220 Celsius until the temperature of water rise to 60 Celsius, right? How much mass of steam has condensed? Yeah, good point. It's a good point. Now, Hari, they are the exam type question. Exam no asking this type long calculation, very simple points asking, right? With the specific latent heat. Okay, this is 500 gram of water. 500 gram of water. 500 gram of water. Am I correct? 500 gram. 500 gram of water at 200 Celsius. 200 Celsius. Now the heat is passing through this water container. The heat, steam is passed into this container or water bath at 100 Celsius. 100 Celsius. Give me a second. Okay, sorry. Now 100 Celsius water vapor. That means the boiling point water vapor steam passing through this water and until it reach to 20 Celsius. Water temperature increase from 20 Celsius to 60 Celsius. Right? The question asks the condensed vapor mass, condensed steam mass. Now the mixture method, right? Mixture method. According to mixture method, vapor release heat. Vapor is the releasing heat because high temperature substance releasing. Vapor released heat energy equal to the water absorbed heat. Now not mention about calorimeter, right? Only water absorbing. Water absorbed heat. Water absorbed heat. Right? Now vapor release heat. Now vapor release heat mean now final temperature of mixture 60 Celsius. No? Okay, vapor release heat. What is the equation? Vapor release heat mean 100 Celsius vapor. 100 Celsius vapor convert to 100 Celsius water and 100 Celsius water convert to 60 Celsius water. That's a thermal equilibrium. Understood? Now, water only 20 Celsius water to no physical state change, 20 Celsius water to 60 Celsius water. Understood? Dinul? For water, no any 20 Celsius water, no any physical state change, but steam is condensing, right? Condensing and reach to 60 Celsius. Hard. Then for vapor, we have to use ML plus MC theta equal to MC theta. ML, we don't know M. M done. The specific latent heat of vaporization is given 2.26 into 10 to the power minus 6, no? 2.26 into 10 to the power minus 6 plus second equation, M of steam mass don't know, M specific heat capacity 4200. Now it is water, right? After steam condensation, now it is water 4200. Temperature difference 100 to 60. Temperature difference 40. 100 minus 60, 40. Okay. Now it is vapor release heat. Nabil, correct? It is water release heat. Sorry, not vapor. Steam release heat or vapor release heat equal to what? MC theta for water. MC theta means mass of water 0.5 kilogram. 4200 into temperature difference 20 to 60. It is 40. 40. 20 Celsius increase up to 60 Celsius. Temperature difference 40. But the question asks what is the value of M? What's the value of M? Hi, Hadam. 2.2 into 10 to the power, not minus 6, no, plus 6. Sorry. It is plus 6. Plus 6. Two 2.26 into plus 6 mean what is the value? 2.26, 226, 1, 2, 3, 4. Correct, right? M plus 4200 into 40. What's the value? 4200 into 40. 168,000. 168,000 M. Multiply with M equal to 0.5 into 4200, 2100, 2100 into 40. 2100 into 40. 84,000. 84,000. 84,000. Correct? They know 84,000. Yes. Hi. Now, at these M values, M gun, add this value into this value, 168,000 plus this value. Zero, zero, zero. What's the value? M equal 84,000. Then you can isolate them. M का isolate करा. M equal 84,000 divided by this long value. එතකොට මේක 30 to 30 cancel out. 84 divided by 4000, sorry, 2428. M equals 0.034. M equals 0.034 kilogram. 0.04 kilogram, that means 340 grams, no? No, 34 grams. 34 grams. 34 grams. 34 grams. Very small amount required. Very small amount required, enough to increase water temperature from 20 Celsius to 60 Celsius. 34 grams only. Understood? Nabil. Upsir. Understood? Good. Nabil, clear? Okay. Okay, let's do only one question and make a amar mein kya? The final temperature you can calculate now. Let's do question number 16. 16 karla apyang. Let's move into now 8. We have another main part, thermal transformation. Thermal transformation, we have 3 transformation method: conduction, convection, and radiation. We have thermal conduction rate calculations as well. Let's final one, right? 100 gram of copper calorimeter contains 300 gram of water at 30 Celsius. 100 gram of copper calorimeter contains 300 gram of water at 30 Celsius. When 150 gram of ice at 0 Celsius is added, the final steady temperature is 5 Celsius. Steady temperature means equilibrium temperature, right? The specific heat capacity of water given and copper specific heat capacity given. The question asks, determine the latent heat of fusion of ice. Fusion means melting. It's a similar word, right? Fusion means melting. Right. The determine the specific latent heat of ice. Okay. How to calculate? Hadam? Sorry. Now, what's the story? It's a 100 gram of copper calorimeter contains 300 gram of water at 30 Celsius. When 150 gram of ice at 0 Celsius is added, the final state equilibrium temperature is 5 Celsius. Hurry. Now, this is the calorimeter. This is a calorimeter. This is a calorimeter. It's contain 300 gram of water at 30 Celsius. It is M100 gram and water 300 gram at 30 Celsius. Both the container and water both 30 Celsius. The system, it is 30 Celsius. Right. Now 150 gram of ice at 0 Celsius. 150 gram of ice 150 grams at melting point 0 Celsius is added into this water bath and mixed in. Stir away. The final temperature was 5 Celsius. 5 Celsius is the equilibrium temperature. Okay. The question asks what? The specific latent heat L of ice at fusion or melting. How to calculate? Okay, now what is heat releasing? Ice or water? Dinul. What is heat releasing? Yeah, not only water. Water and calorimeter release heat. Water release heat plus calorimeter release heat equal to ice absorb heat. Okay. Now water release heat, water only releasing mean water temperature decrease 30 to 5 Celsius. No any physical state change. Water temperature 30 to 5 Celsius. 30 Celsius water, 30 Celsius water convert into 5 Celsius water. No any temperature physical state change. Then MC theta. Plus calorimeter also same. 30 Celsius initially. It's convert to 5 Celsius. No physical state change. MC theta. Right? But ice, what happened? First, 0 Celsius ice convert into 0 Celsius water. 0 Celsius water convert into 5 Celsius ice, 5 Celsius water. Then you have full idea about mixture method calculations, right? Everyone same. If there is no physical state change, only MC theta. If there is a physical state change and change the temperature, ml plus MC theta, right? It is equal ml for physical state change, for temperature change MC theta. Any doubt? Still, if you have doubt, please ask. Then we can substitute values. Water 300 gram, 300 over 1000, 4200. What's the temperature difference? 30 to 25. Mass of calorimeter 100, that means 100 over 1000, that means 0.1, into specific heat capacity of calorimeter 390. Temperature difference 25, same. 25. The mass of ice cube 150 over 1000. L don't know. The mass of water, now water, ice water not 150 same mass over 1000. Now water specific heat capacity 4200. Water specific heat capacity 4200. Temperature difference 0 to 5 Celsius 5. Only 5. Not 25. At the final state 0. Now melted ice converted to 5 Celsius. Okay. Now 20 to 20 cancel. 0 to 0 cancel. 20 cancel. 0 to 0 cancel. 0 to 0 cancel. 0 to 0 and 20 cancel. Hurry. Now get the values first. 42 into 3 into 25. Hurry. Taggardan values 42. 31,500. 31,500 plus 39 into 25. 39 into 25. 975 equal 15 over 100 means 0.15. 0.15 L plus 15 into 20, sorry, 42 into 5. 15 into 42 into 5. 3150. Now you can isolate the L is the answer. මොකද කරන්නේ මේ දෙක ඇඩ් කරමු අර සබ්ස්ට්‍රැක්ට් කරමු. 31,500 plus 975 minus 3,150. (975) minus 3,150 equals 0.15 L. Now you can isolate the L. L equal, what is this value? මේ පැත්ත value එක කීයද? $32,400 or 29,000. Left side do you met කීයද? $29,325 divide by 0.15. Then you can get the final answer. What's the final answer? Is it 195,500? JkG minus 1. JkG minus 1. Joules per kilogram. Joules per kilogram. JkG minus 1. JkG minus 1, 195,000. Okay, any doubt? Any doubt? Okay, go to the tute. Final question also same type question. Final one also same type question. You can work on that. Give me 1 minute. Okay, sorry. Okay, let's move into the final part of lesson. It's thermal transformation. Thermal transformation. Okay, this experimental setup we can discuss in the practical class. Don't think about that. If you can remember, if you can understand only mixed method, that enough. Mixed method calculation, that enough. Don't think about these expressions. You can read these additional things. That's thermal transformation. Yeah, this is our next lesson. The thermal transformation. Thermal transformation. This is the final part of heat lesson. So do we have practical classes on this lesson? Yeah. Each part we have practicals. We have specific heat capacity and thermal transformation, conduction, the specific latent heat. All we have practicals. That we can discuss in the practical classes. Practical classes mean in the practical guide discussion we can discuss. So actually this practical knowledge you only need for final structured essay. Final structured essay only asking based on practicals. Other all questions normally no essay questions asking about practicals. All essay questions asking this theory. Theory tama hala තියෙන්නේ. Hari. Hari. බලමු. Okay. What's the meaning of thermal transformation? The thermal transformation. The thermal transformation means the heat energy transfer from one place to another place. That's a simply the thermal transformation. The thermal transformation is the process by which heat energy is transferred from one point to another point due to the temperature difference. You already know always heat transfer from high temperature to low temperature. High temperature to low temperature. The heat energy always flowing from high temperature to lower temperature region until thermal equilibrium, right? That we already discussed. That means think the heat energy we already discussed in the mixture method. The metal piece heat continuously release to water absorbing until thermal equilibrium, until both substance reach to same temperature, until thermal equilibrium, right? Right. Okay, there are three main thermal transformation methods. What are the methods? The first one, conduction, convection, and radiation. That you already know in O-level time. Conduction, convection, and radiation. Okay, what's the meaning of this conduction? What's the meaning of the conduction? What's the meaning of conduction? Conduction. Okay, remember we have three main methods. We have three main methods, right? Thermal transformation. Thermal transformation. Okay, there are three main methods of thermal transformation. Main methods. What are the methods? Conduction, convection, and radiation. Conduction, convection, and radiation. Okay, first of all, I will explain one by one what is a conduction, what's a convection, and what's the radiation and its effects, its effect factors. But finally, I will go move into calculation. The final part of lesson is thermal conduction rate. How to calculate the conduction rate. First come to conduction. Conduction is always, that's a heat transformation method, always heat transfer from solid substance. Solid in tama make a when. The conduction is the main thermal transformation method through solid substance. Solid substance. Right? Convection. Then what is the substance? Convection. You met. Convection. What is the media? The conduction liquid? Only liquid. Is it only liquid? Very good. Fluids, liquids and gas both. Liquid and gas. Okay. Through a liquid and gas, both mediums, the main heat transformation method is convection. Convection. Then what is the media for radiation? The radiation thermal transformation media? Radiation. Met me. Then solid, liquid and gas all completed. Then what is the media for radiation? Nabil. You met? You know, radiation. It's solid, liquid or gas. No any media. Very good. No media required. No media required. No any solid or liquid. That means not molecule involvement. Not molecule involvement for radiation. Right. Now let's see one by one. What is the conduction? What is the convection? What is the radiation? And what are the differences between conduction, convection, and radiation? Hari. Very important part. Hari. Our first topic is conduction. Conduction. Now you already know the conduction is the heat transformation method through which substance? Solid, liquid, or gas? Only solid. Only solid. The thermal transformation method through only solid. Conduction. The first one, conduction. Conduction. Okay, how to conduct? Conduction happens. Okay, do you know, can you explain a very simple example for conduction? Conduction. Okay, you have a cup of tea, heated tea. Mehmet, cup of tea. Then, oh, what? Cup of tea, right? Then you put a spoon, hand that down. Then what happened? Now initially this end is, now it is heated end, and this is cool initially. But what happened gradually? Spoon get heated. The free end also heated gradually. This is a conduction. This is a conduction. This is a conduction. The heat energy flowing through a solid medium. How to transfer? That's the important thing. Okay, now you know if it is solid media, it is molecules are highly compact and very strong intermolecule bonds between them. Right? Molecules highly compacted and very strong intermolecule bonds between molecules. Highly compacted and very strong intermolecule bonds between molecules. I think you can remember. Very simple. They are highly compacted and very strong intermolecule bonds, right? Like this. Molecules highly compacted. Molecules highly compacted. And very strong intermolecule bonds. Okay, molecules highly compacted and very strong intermolecule bonds. Now think this is this side temperature 100 Celsius. The opposite side 10 Celsius. It is same as our spoon example. Spoon එක වගේ the tea එකේ තියෙන එක 100 Celsius. The other end normal temperature 30 Celsius. Right? Now what happened? What happened? The tea is liquid. The liquid part I will explain in the next part. Now the heat energy absorbed by this end molecules absorb these, provide heat energy, right? Heat energy absorbed by heated end molecules. Then what happened to their when it is absorbed, what happened to their molecule kinetic energy? Start to vibrate, increase in their molecule kinetic energy, right? Increase in their molecule kinetic energy. I will what happened? The heated end molecules, heat energy absorbing and increase their temperature increase and increase their kinetic energy, right? Actually temperature mean kinetic energy, increase their kinetic energy, right? It's absorb some heat and increase their kinetic energy, right? Due to this kinetic energy increase, what happened to the vibration with collisions with nearest molecules? It's collide with nearest molecule. Collide mean it's hitting. එයාලා ගිහින් ගැටෙනවා. හරිද? මෙයා ගිහින් ගැටෙනවා මේ nearest molecules, right? It's collision. Collide වෙනවා. Right? Collide. What happened? These heated molecules increase their kinetic energy and collide with nearest molecule. As a result of this collision, what happened? Part of heat energy transferred to the nearest molecule. Collide with the part of heat energy. Our nearest molecule also start to vibrate. Then this molecule again collide with other nearest molecule. Nearest molecule collide, right? Again molecule to molecule heat transformation process we called as a conduction. The molecule to molecule heat transformation process of any solid object to any solid object we called as conduction. Okay, this is a method. Molecule to molecule. The main characteristics is no any molecule net movement. Molecule like a method. Understood? No any molecule movement. Only molecule vibrates and molecule to molecule heat transformation we called as conduction. Why it is molecule not movement? Because they are highly compacted. Molecules are to move in the back because it is not a fluid. It don't have flowing property. Molecules are highly compacted. Therefore, molecule heat energy absorbed and it's transferred to next molecule like this. It's continuously molecule to molecule heat transfer. No any molecule movement. Understood? That we called as conduction. Understood? Understood? If you have any doubt, please ask me. Nabil, clear? Afsal? Okay, I think this conduction, convection, radiation, I am not going to give a short note. It is clearly available in the tube. Clearly, I have given in the tube. The conduction is a process, heat transfer that occur mainly in solid substance due to collisions and vibrations of molecule. Due to collisions and vibration of molecule. When one end of solid is heated, molecule at that end gain energy. Heat energy absorbed by this molecule. And these molecules vibrate more vigorously and collide with nearest molecules. Energy is transferred from one molecule to the next molecule. One molecule to the next molecule. If you want, you can note down. The molecules know any movements. It's only vibration. That's the main characteristic. Molecule know any net movements, it's only molecule vibration and transfer to next molecule, transfer to next continuously until end, right? That's the conduction. It is given. No net movements, molecules from one place to another, right? No net movements. Heat energy is transferred through molecular vibration and collisions. Molecule vibration and collide nearby molecules, and again same process, right? Most effective in metals due to free electrons. Yeah, metal is a solid. Okay, any now metal mean they are good conductors. Metals mean good conductors. If you got the wood, they are poor conductors. They are free electrons very low. Therefore, it's very difficult to transfer heat energy, right? Okay. The conductivity also depend on the free electrons that we can discuss in the calculation part. Example, metal rod becoming hot at the other end when it is heated. Yes, heat transfer to the wall of cooking pot. Yeah. Now, any solid object, what is the heat transformation method? To any solid object, what is the heat transformation method? It is conduction. In the conduction, molecule to molecule heat transfer due to vibration and collision. Kinetic energy and collision. Vibration and collisions. No any net molecule movement from one place to another place. Hari, you met? Clear? Hari. Now, solid objects, okay. Solid objects only conduction. Only conduction is a method. Heat flowing through solid object. Okay. If it is fluid, liquid or gas, the heat transformation method, convection. Convection is a process that heat occurs liquid and gases, fluids through the actual movements of molecule. Okay, this is a mechanism. Very simple story. This is a simple story. Okay, the second one, convection. 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 Okay. Convection. What's the meaning of convection? You know, convection is take place through liquid and gases, mainly through fluids. Fluids liquids and gases. Okay, first let's think about liquids. Water boil karna. In the boiling of water, what happened? Think it is a water bath. Now it is heating from downside, heating from bottom end. Now think it is water. You know, water also, it is liquid also made by molecules. Molecules. The special characteristic of liquid molecules, they don't have very strong intermolecule bonds. They are medium level. Therefore, these molecules are moving, possible to flowing, right? They have viscosity. Right? These molecules possible to moving through the liquid, right? Molecules move and pull. Okay, therefore, when it is heated, what happened? bottom molecules at this bottom end, molecules absorb heat energy. Molecules absorb heat energy. Then what happened? Their temperature. The temperature getting increased. Temperature getting increased means what happened to their density? Remember, density getting decreased. The temperature increasing, due to that the density of substance, the density of molecule getting decreasing. Compared to this end, upper side, many molecules මොකද වෙන්නේ? These molecules are, they are temperature low, cold. Still they are cold and their density is greater. Comparatively it is greater. Right? Therefore, what happened? These high density molecules, because high dense molecules going down and low density molecules going up. This is a circulation process. When it is continue, the entire water bath is heating. When it is continue. Okay, that's the convection for liquid. That's a convection for liquids. Understood? Do I need to explain again? The main characteristic is not like conduction. In the convection process, molecule has a net movement from one place to another place due to density difference. Due to density and temperature difference, molecules they have a movement. They have a net movement from one place to other place, high density to low density. Right now it is continue. Low density particles heated and low density particles going up, and cold particles come down due to the high density. Okay, these circulates. Molecules circulate like this. That's why the entire water bath is heated. Getting heated. Understood? Okay, it is the second thermal transformation method, convection. Okay, now what happened in atmosphere? Air mean gases. How to convection take place to gases? I told not only liquid and gases, both mediums, the heat transformation method is convection. Okay, do you know? Now think it is a water surface, right? Water surface. In the daytime, due to sunlight, what happened to the water surface temperature? The water surface temperature getting increased. This water surface temperature getting increased, right? Due to that, what happened? Water vaporized, that we called not as vaporization, it is evaporation. Evaporation means liquid water convert into water vapor less than boiling point, that we call as evaporation. Okay, now they are water vapor, right? Water vapor. Now it is gas. Vapor, right? Gas stage. Water vapor, right? Heated water vapor. Okay, how about the temperature of this water vapor? They are highly heated water vapor, and their density is low. Right? Their density is low. They are high temperature and density low. Comparatively normal atmosphere also, some water molecules contain in atmosphere, some water molecules and other gases. They are comparatively cold. Cold means low temperature and comparatively high density. Therefore, what happened? This high density cold molecules going down and low density water vapor going up, right? Again this area, again it is cooled air, cool gases again circulate. මෙන්න මේ විදිහට තමයි that we called as evaporation and transpiration. Evapotranspiration take place for the water cycle due to this convection, of gases. Understood? Heated water vapor or any gas flowing upward due to the density difference and temperature difference. Make a delta. Then at the upper atmosphere, what happened? They, due to the low temperature, they condense and make clouds. The convection rain is formed due to this scenario. The convection rain is formed due to this scenario. Do you know what's the convection rate? You mean? Do you know what's the convection rate? Normally, Sri Lanka, අපිට තියෙනවා 4 rainfall patterns. 4 rainfall patterns. The first one, make an extra thing, but it will be important. Normally, we have 4 rainfall patterns. The first one, northwest monsoon, not northwest, southwest monsoon. Southwest monsoon. Do you know what's the southwest monsoon time? May to September, right? May to September. එතකොට මේ මොන monsoon එකද? Southwest monsoon. Second one, intermonsoon number 1. Intermonsoon number 1 mean September වලින් පස්සේ October, November. Right? Intermonsoon number 1. The third one, northeast monsoon. Northeast monsoon, it is not the lesson, වෙන එකක් කියන්නේ. හරි. The Sri Lankan rain patterns. Northeast monsoon, do you know what's the time? Then November, December to February. There is another one, fourth one, දැන් තව මාස දෙකක් ඉතුරුයි නේද? මැයි වලින් පටන් ගත්තේ. Intermonsoon number 2. What's the name of that? The time period, March and April. Okay, that's a schedule. Okay, you know southwest monsoon mean at that time, due to the pressure difference of the earth, the මෙහෙම earth එක ගත්තාම equal, this is the Sri Lanka, no? කොහොම තියෙන්නේ මෙහෙමනේ. මේ වගේ, right? Now normal this southwest monsoon period the pressure of Earth that we called as North Pole, sorry, the North Pole, then this is South Pole, right? The mehe pressure South me North Pole pressure is less than South Pole pressure is greater. South Pole pressure is greater. Therefore, wind flowing from South Pole to North Pole. South Pole to North Pole. එතකොට මේ විදිහට යන wind එක ලංකාවට මොන පැත්තෙන්ද entrance වෙන්නේ? The wind flowing from North Pole to South Pole, the enter to the Sri Lanka from which direction? Southwest. ඒ කියන්නේ මොන පැත්තද? නිරිත දිග. ඒක අපි නිරිත දිග මෝසම කියලා කියන්නේ. Southwest monsoon. Right? දැන් අපි පොඩ්ඩක් ඇලවෙලානේ තියෙන්නේ මේක. එතකොට මෙහෙන් තමයි not south, southwest direction. Right? Understood? That's why we call southwest monsoon. Understood? Now this, it's enter to Sri Lanka from southwest direction. Southwest direction, and Sri Lanka, there is a middle state, middle mountain. This water vapor entrance from southwest direction and hit with this make a gihilla happen, right? Due to that, the water vapor contained in this wind flowing up. Water vapors, it's forming clouds. They are monsoon rains. They are not related to convection. Monsoon rains not related to convection. It's completely due to monsoon. Monsoon pressure difference of the earth. Pressure difference of the earth. Okay, understood. It is southwest monsoon. Southwest monsoon. Right? Then northwest monsoon. Northwest monsoon at that time, the May time normal pressure same. That means October, November time pressure same. If it is pressure same, no any air flowing. No any air flowing to specific direction. Specific direction. Due to that, Sri Lanka, not only Sri Lanka, all countries, no any specific air flow into same direction. No any monsoon rain. No monsoon rains. At that time, the rain is convection rain. Convection cloud form wind, right? Because no, the main type convection. It can hamadam convection, but in monsoon period, the main rain is monsoon rain. The water vapor mainly coming from monsoon wind. Not by main one is not convection. But at this intermonsoon type, intermonsoon both poles regions pressure same. Due to pressure same, no any airflow. Due to that, October, November, May time koi velawada wahinne me intermonsoon rains, morning or afternoon or evening. මොන වෙලාවටද වහින්නේ? What's the raining time? දැන් මෙන්න මේ සෙකන්ඩ් එකේ නම් හරියටම බලන්න පුළුවන්. Intermonsoon number 2 March and April. අවුරුදු කාලෙට මොන ටයිම් එකකටද වහින්නේ? The other characteristic of this intermonsoon, highly thundery and lightning. අකුණු වැදිනවා වැඩි. මොන කාලෙද වහින්නේ? Evening. Yeah. Evening, because daytime very hot for convection. Convection when very hot. At evening, forming clouds and rain start. I got. Then what happened in the northeast monsoon? After this pressureless period, same period, the North Pole pressure getting, North Pole pressure getting greater than, pressure change, Due to that, the wind direction getting difference. Winds coming from North Pole to South Pole. With wind coming from North Pole to South Pole, North Pole to South Pole. Then where it is entrance to Sri Lanka? Northeast direction. Northeast direction. Same thing, it is hit with middle mountain and going up water vapors and form clouds and precipitate rain. Normally this monsoon period, no any specific time to rain. Then it's monsoon rain. What is the monsoon type? Southwest monsoon. Normally monsoon time, monsoon rains, no specific time. It can somehow right? Daily rain. Right? Okay, that's the nature. Normally, do you know which rain is greater? Make the valley. Southwest monsoon or northeast monsoon is greater. Gotak rain again. What do you think? Other thing, southwest monsoon, mainly the rain coming from wet zone of Sri Lanka. The northeast monsoon, mainly rain for dry zone of Sri Lanka. This dry zone and wet zone actually may separate according to this rain type. Normally, southwest monsoon rain is greater. It can southwest, it can wet zone negative. I know valley. A reason. What's the reason? It has a scientific reason. Math එක බලුවනම් තේරෙනවා. What's the reason? Southwest monsoon, the rain is great. What's the reason? Dimit, what do you think? Southwest monsoon එකෙන් වැස්ස වැඩි. ඒක normally if you got in as a measurement, it is more than 2,500 millimeter per year. Yeah, it's vast ocean here. The may පැත්තේ completely the wind coming from over the sea. Therefore, it's carry lot of water vapors, huge amount of water vapors. That's why the wet zone is made. The wet zone has greater precipitation compared to other areas. Northwest monsoon also carry water vapor, but it has water vapor amount, but it's coming out of land areas. India, a land area haranen poti sea area it's also a water vapor, but it is comparatively low. I got. That's how the dry zone and wet zone is separate. I think you got some idea. It's another, I think, geography or maybe karna dana mami tikak kirdu. Okay, I want to show you the north intermonsoon number 1 and intermonsoon number 2. They are convection rain. The convection rain mean daytime it is highly hot. Hot mean it's evapotranspirate, and evening time clouds forming and rain. Right? That's convection rain. Normal intermonsoon time, the rain is convection rain. Other rain type is monsoon rain. Hurry. Okay, that's the convection to liquids and gases, atmosphere. Any doubt? Do you know Bay of Bengal wala low pressure එකක් වුණාම මොකද වෙන්නේ? Due to formation of low pressure. Do you know that we call as hurricane is forming? Right? Hurricane එකක් වෙන්නේ මෙහෙම. Now this is a normal condition. This is a normal condition. But if there are any low pressure area low pressure area form close to our country. It's a abnormal condition. Not a natural thing. It's a natural, but it is not a normal scenario, right? If they are in low pressure is forming, it's a low pressure. මේ හරිය low pressure එකක් එනවාද? Pressure low. Then what happened? The wind from all area come into this point. Due to that, this huge amount of water vapor transfer to our country. අපේ country එක උඩින් තමයි යන්නේ. That's why it's forming floods due to the low pressure scenarios of Bay of Bengal. Understood? It's a special scenario. That previously I explained the normal story, normal scenario. Understood? This water vapor, huge amount of water vapor. මොකද මේ හැම පැත්තෙම එනවා මෙහාට. Yeah, every direction carry water vapor, and it's a huge precipitation. Unexpected precipitation is take place. That's why Ditwa last year, that was a hurricane. Hurricane mean this low pressure, this wind speed, this wind flowing speed, මෙතන speed එක, if it is 85 kilometers per hour, if it is greater than 85 kilometers per hour, it's that we consider as hurricane. සුළි කුණාටුවක් කියලා කියනවා hurricane එකක් කියලා. Right? ඒක මේ speed එක, ඒ කියන්නේ low pressure එක වැඩි වෙන්න when it decreasing the pressure very low level, the wind speed getting very high, that we call as hurricane. Okay, that's a convection. Let's go into final one, the radiation. Okay, I have given all data. Fluid near to heat, the density decrease. It's low density fluid rise upward, and cold high density fluids move downward and repeatedly. This continuous circulation, its convection occurs. Key characteristic: heat transfer together with motion of molecules. There is a net molecule motion in the convection. That's the main. Liquid and gas both. Net molecule movement occurs inside fluid. Cannot occur in solid. Yeah. Solid, because solid, they are highly compacted, therefore they cannot move separately, right? Example: boiling water, sea breeze, and what is that? Sea breeze and land breeze. Okay, that's homework. You have to find about that. I will ask next day. Hot air rising from heater. Yes. Okay, let's go into this is a homework, right? You have to find out. It's the basis convection, right? Convection එකෙන් අපි කියනවා මේකට මුහුදු සුළං ගොඩ සුළං කියලා. Right? Sea breeze and land breeze. You have to find out. Okay, radiation. Okay, final thermal transformation method, radiation. Okay, radiation. What's the meaning of radiation? The radiation of process is transfer without use any material, without use any molecule. Heat transfer from one place to another place we called as radiation. In radiation, heat transfer through electromagnetic waves. In short form, that we call as EM waves. EM waves. Heat energy is emitted as infrared radiation. These waves travel at light speed. Normally, these EM waves travel at light speed, and it does not require a media and occurs when in a vacuum. Not only vacuum, normal atmosphere also heat transfer to radiation. Normally sunlight transfer to earth due in the radiation process. No molecules usage. No molecules usage. Okay, that's example. Example, heat transfer from sun to earth, feeling warm from a fire without touching it. Yeah, if there is any fire, the heat we can feel due to the radiation. We can feel heat due to the radiation. Due to the radiation. The radiation. Okay, the main characteristic of radiation, it should have considerable temperature difference. Considerable temperature difference. Normal, do you know what is the sun temperature? Surface of the sun. Temperature of the surface of sun. 6,000 6,000 Celsius. Normal earth temperature minus 18. Without sunlight, minus 18. That's right. 6,000 to minus 16. Sorry, minus 18. That's why heat energy transfer from high temperature to low temperature. It should have comparative considerable temperature difference. ලොකු වෙනසක් තියෙන්න ඕනේ. නැත්තම් radiate වෙන්නේ නැහැ. Right? And other thing, if it is smooth and white color surface, it's highly electromagnetic waves, highly reflectable. Highly reflectable means no, very low absorption. Very low absorption. That's why school uniform, test cricket uniforms are made in white colors. White color. It is very low absorption of EM waves, electromagnetic waves. But dark and rough surface, it's highly absorb electromagnetic waves. EM waves highly absorb. Highly absorb. Then අපි black color tank එකක් තිබ්බොත් with water, it's highly absorb heat, highly heated water. If you got a white color tank, it's low absorption. Low absorption. Hard. Okay. Remember, in the radiation, no any medium is using heat energy transfer without medium as electromagnetic wave. The energy obtained from electric and magnetic field of this electromagnetic wave, right? No any medium is using. Hari. Now actually the basic theory part is completed. I explain only conduction, convection and radiation only today. We need one more day for complete heat lesson because we have calculation part as well. Hari. Do you have any doubt from today discussion? Any doubt? I got radiation. Radiation means heat transfer from one place to another place without any media as electromagnetic waves. Electromagnetic waves. You met? Clear, right? Hi. Then let's complete lesson. We have another calculation part. Make it, you know, yeah, this part, this equation. This equation, the thermal conduction rate. Thermal conduction rate. Yeah, this equation. Q over T delta. Q over T Ka delta theta over time. Okay, karami ivarai. Okay, then let's complete the lesson next week. And after the complete this lesson, you have exam. Simple exam. 2-hour exam. Next week, not Friday, no? No. Monday is 4. Yeah, then 28th Sunday you have class. Okay, then let's complete thermal conduction rate next day. Goodbye. Good night.